Hello, welcome to Fox Lab. As you know, FoxParticles 2.0.0 is released, and to tell you the truth, while I creating this tutorial before, I found a bug and I immediately updated the plugin for 2.0.1, and all of you might get that updated version in your mail. Check your mail if you didn't see that. And there was some problem with my velocity force, and it's fixed now. And okay, let's move to the tutorial. In this tutorial we'll be seeing p-shape tag and p-velocity force. We'll be creating this thing. As you can see, my particles are actually some balloons right now, and you might think, what is the new thing here? I could already give a cloner and put the group inside that, then you will get a balloon, right? But you can see here my balloons animations are actually offsetted. Whenever that particles are created, the balloons will be having that animation, then it starts to fly. Okay, that's the difference with our cloner setup and this p-shape tag. Okay, sorry, FoxShape tag. P-shape is actually the t-particle term for that, yeah, let's move to the tutorial part. I'll create a new project, and for that balloon thing I actually get it from the recently used one, a hot air balloon from our C4D assets, but this is too heavy for a mesh. We might need to reduce it a lot, and I actually did that with this is the balloon thing, and I just made it a balloon, and let's go for the cube thing, and let's make it one. This is the box part and this is the balloon part, right? And we will reduce that with our cinema 4D's on polygon reduction. Press alt. Before that I'll turn this thing on so you can see what I'm clicking and typing. Okay, so now let's select the balloon and press alt and polygon reduction. Give it some time, it will reduce your particles count. Let's reduce it maximum, maybe up to 99%, and we can give it some boundaries too. Let's calculate that one, and that's enough. I know the material is messed up, but we'll make it right in a minute. And we'll press C, and that is baked on this balloon. Now our balloon is low poly. With that low poly didn't, okay, it didn't affect on the shape, so it's okay. Let's move to the box, and let's try that again with our polygon reduction. What is this polygon reduction doing here? Let's give it some time, and it's calculating. There is a lot of polygon in this thing. For what we are doing, we might not need this box to be low poly, but we are doing that, so let's keep it that way. And we ended up with, what is it? Come on, yeah, something like this. I know, terrible topology, but we'll go for 98. Maybe UV boundaries too. We don't need that, but whatever. Okay, I'll speed it up, and boom, there is it. And that might be okay. Press C again, and we baked it in this one. For the box part, we can leave that as it is, but our balloons material is messed up. I just delete this polygon selection, and yeah, that's our balloon material. I think that this is that one. I'll just create a gradient here. Let's go create a gradient, and let's give this one an orange shade for, I don't know why that's bug is there. Okay, let's create an orange shade for our FoxParticles shade, maybe somewhere there. And we can make this thing step instead of, and this one too, step instead of smooth one. Okay, so we get a shape here. I know the polygon count is too much, I think. Why is that giving a shape? Okay, anyway, it won't be noticeable when we do right click and double the nodes, and double the nodes, maybe one more time. Yep, it is noticeable, but might be we don't have to go with the 99%, maybe a 98% might do. But yeah, that's how I reduce my polygon counts, and it is essential for this part. Why I did that, I'll show you when we get the, okay, so we got the balloon, and now we need both our polygons, this axis thing, center point here at the exact bottom, or slightly offset to the bottom, not on the mesh, just slightly offset, because when we start our p shape or pre-corner on our particles, it will be starting from this point here, so it will be moving upward, or some rotation or everything will be on this axis. So I'll take this down and change our particle, maybe not like that. I'll select our box thing and go with our axis center. I docked it here. You can go, I believe it was in mesh, and I don't remember. Yeah, mesh, axis, and axis center. I'll go with the -y and execute. So it is exactly on the lowest position, lowest point of this thing. And I'll put our balloon inside our box. We need both our axes at the same position, so I'll put our balloon inside our box. I'll turn this thing on and change x comma 0 y comma z into 0 and press enter. The axis will be on the exact same position of its parent. Now I'll take it out, and our balloon setup is here. I'll save it in case. Okay, now let's animate our balloon thingy here. For that, we have to do a PLA animation for this one, for points to be calculated as, sorry, points to be animated as it's opening up. You can do a cloth sim, I think, but it will take some time. So for this one, I'll just use a FFT deformer. So I'll press shift and add FFT deformer. It will be automatically added to your balloon, and the size will be adjusted. And if you haven't pressed that shift, you will be left with this. Not a problem, just add that inside the balloon and fit to the parent. Okay, now let's move to the point mode, so we can access the FFT deformers points. And maybe somewhere here I'll put all the points and make a keyframe. Before that, we need to turn this on, so it will store the point positions. It is actually PLA something, point level animations will be stored in this one. Okay, so let's add a keyframe in the 20th frame. It doesn't matter, it matters, but I'm not going for an exact numbers here. You can go with the 30 and it will be exactly 1 second. Why can't we do that? Okay, so let's go to somewhere 20, and I'll change the tool to rectangular selection and select the top one. scale, and I'll scale this one to somewhat smaller, and maybe select these points. I think I selected all the points. Yep. And reduce a little bit more, and we'll make that shape here and store it here with the keyframe. And maybe somewhere here we'll go bit more smaller, and little more smaller here, maybe even a little bit down, and our bottom, sorry, with the selection tool, bottom ones too, and yep. And I'll store that one, and now first one I'll select all the points and just reduce. Before reducing, I'll press spacebar twice so I can go back to this scale tool, or you can just select the scale tool and go to modeling axis and change the Y to -100, so the axis will be stayed on the lowest part of this mesh or the FFT. And we can go back to sorry, not E, T, and we'll go back to here, maybe a little bit smaller here too, and let's do that, and let's hit play and playback. Nice. I'll hide the FFD, but it is not organic. Let's say organic here. Okay, the animation is not smooth. You can go with F curve and try to do that, but the easier method is adding a jiggle deformer. So I'll add a jiggle deformer after the FFT, not after the balloon, after the FFT, and we'll give some stiffness, less structural, and many more drag, and let's hit play. There it is working. Maybe a little less drag, and I think, yeah, we need that springiness. I like that springiness. And yeah, that's our animation. Now we have an animation in FFD, and the jiggle is smoothing out. You can cache this as a point PLA cache, not an Alembic one. Alembic one won't work with this method. Alembic one will work with shape tag, but for this option, like this offsetting animation, we need keyframe animation, so I'm not going with an Alembic thing. I think this white object is a copy from that. It doesn't matter. Okay, anyway, let's hit play, and our balloon is inflating, deflating, if inflecting, I'm not sure. Anyway, it's beginning, yeah. Okay, like that, it is a word. Now let's create our Fox particle. Let's create our Fox particles from Fox emitter. Okay, there are some new objects. I'll be creating some tutorial for that too. Now we just need our Fox emitter here, and let's put that in object mode instead of shape. Now we need a object. We'll create a landscape, and with our balloon ratio we need to increase our landscape scale a lot. Maybe we don't need that height that much. Okay, now we get a balloon setup, and landscape for particles. We'll hide our balloon. Just create a null and hide our balloon for now. Okay, let's rename that to balloon. Okay, now let's create our particle. For that, in Fox particle, in object emission, we need a landscape, but you can see it should be editable objects. So we'll press C4, make it editable, or you can press this button here. Anyway, we'll put that inside our objects list, and we just need one object there for now. Let's hit play, and our particles are flying. Let's give it some time of maybe 500, and in object we'll go 500 lifetime because we don't need that to die, and we'll emit particle non-stop. So it will be emitting particle up to the 500 frames or whatever frame we'll be giving there. Okay, now our setup is almost there. Let's hit play, and we don't need our particles to fly right away. We need our particles to burn, then our balloon to be deflated, okay, bigger, and then the particle should be flying up, right? So we'll go with 0 speed for now. Then the particles are staying there. One particle is flying because the refresh issue. For that we can do one thing. We can put -1 here, and now if we press back, the particle will be gone. All the particles will be cleared, and from the 0 the particles will be newly created. Okay, that's a tip I get from Chris Smith. He started to do that recently, and that was a great tip. Anyway, let's move on with our particle lectures. Now all our particles are born and staying in our our particle emitter, the landscape, right? Now we need to gradually increase the speed. For that, there is our new tool here, FoxVelocity force. Before applying it here, I'll show you how FoxVelocity field to work. FoxVelocity force work. I'll create a new Fox emitter, and if I hit play now, the particles are moving. I'll give it a group of, I don't know, group 1 maybe, and give it some color, maybe a bit more light yellow, so that you can see that in your particles. Maybe I'll create a new, sorry, not maybe, for sure I'll create a new group, and that's group 2 with that color. I don't know what that color bug is. Anyway, okay, it only comes when I record. Yeah, let's change this particle into group 2 with a field. Okay, I add a group field. You can go there. Yours won't be here. Yours will be inside this one, and we need a group field folder. None of those as straight will work. You need a group field folder, and we can add a FoxParticles Fox field. Now the Fox field is recognized by Fox emitter, and you need two groups inside that. The first group, which particle should be affected, and the second group will be what particle it should be converted to. Okay, now we'll add a box field, or linear field will work, but let's add a box field here right now, and maybe not that thick. Let's put it here and hit play, and it's turning into that pink. I believe you can see that pink color. Maybe let's go with something vibrant. Is green vibrant enough? Okay, we'll go with a cyan color. Okay, and for visualization we can do a tracer too, why not, and add all groups in that, and we can see our particles flowing through and changing to cyan color, or the group 2 in between though. Okay, and let's add a turbulence for that too. For that, go to simulation and get a turbulence. We'll give scale of somewhat here, and maybe 50, and let's hit play. It won't work because we didn't convert it into FoxParticles force. So we'll add a Fox force tag, and then now it will be working, and you can see that it's working and the particles are flowing. with the turbulence, and it's for there is no group limit there, so all the particles are affecting it, right? Okay, you can now let's add our FoxVelocity force, and after we add that, let's hit play, and what happens? All the particles are going straight. I'll tell you why. Now let's add the FoxVelocity force group limit into group 2, and our particles will be having some movements there, and then go straight. You can see that if I select this tracer one, they go straight, then again with the turbulence. Maybe we'll give 300 frames here too, and life of 300, and a non-stop. Okay, the particles are affecting with turbulence, then not on the tracer, and sorry, then not on the group 2, then again with the group 1, right? So the velocity force is actually killing the turbulence field, right? Not actually. This is actually doing something here. It is actually replacing the direction with z. Okay, so if I put 0 here and 1 in y direction, let's hit play, and the particles are going up. You can see the particles are going up. What if we have one here and one here? Let's hit play, and the particles are going up and on the z direction. If I put one here, let's hit play, and this up z direction and x direction. You can do for -1 also for this side. Let's hit -1 and hit play. It will be turning that side. Okay, so we can adjust the direction of our particles here, or even speed. If I put maybe 10 here, and let's hit play, and the speed will be slowed down to 10, and whenever that got out, it won't be going back with that. The speed is actually increased with because of this turbulence, but here it is slowing down for that 10 speed, right? And it is okay, so that's how it works with a FoxVelocity force, and we can change that speed only. Now we don't have to change the direction, but it is slowing down, and the direction thing is still work. Maybe I'll increase the speed with 120, and it is in maybe 120 is too not that much of speed. We'll go with maybe, I don't know, 300, and the speed is increased, and you can see the particles are moving whatever the angle they are coming with, and sorry, the axis they are coming with, and they just increase the speed. Okay, now the direction is not affected right now. You can change that to direction only, so the speed will be constant, and you can change the direction in between way, and there is variation for both direction and speed. Okay, there's also something else. Now let's put back to speed, and maybe 10, I mean 10, and let's hit play, and the particles are there, and it is slowed down. If I change this to add, let's see, our speed will be increasing because our particles have already a speed of 100 and something coming from turbulence too, and it will be added 10 in every frame. Okay, let's see that again. I'll yeah, okay, let's put one here, and let's hit play, and it will be increasing speed a bit. Maybe 1 is too small, 3 or 4. Okay, 10 is the right number, and it is increasing the speed, right? And then will be added in every frame. So whenever this hit here, it will be 100. When it get inside, the next frame will be 110, next frame will be 120, the next frame will be 100 and something else, okay, 130, it's so on. Okay, that's the evaluation into add. And there is also multiply. Multiply will also, you can see, boom, that's because that speed is in 10. We'll go with 2, and it just doubles in every frame, and that is not a good thing here. So maybe you need to have to launch something, so it will be like this. You can do that too, or you can just calculate it in per second. Now if I hit play, not every frame there will be a increase of doubling of the speed. You can have that slowly, in every second it will be doubling the speed. Okay, that's the multiply and per seconds. So that's FoxVelocity. Now let's go back to our project, and let's give it some speed here. Let's add a FoxVelocity force and hit play, and the particles are moving, but it is moving in the wrong direction. We need that in up direction. So 1 here, and hit play. You can see that our particles are moving up. We need to put this in add mode, because I'll show you why. It when it is born, maybe speed 100 is too much, or maybe we can go with the per second option. So it will be created and get some time to get to that velocity, and it will be increasing velocity, and just like the balloon, it will be increasing and increasing and increasing. As it gets to the surface of sky, it will be increasing the speed in every second. So this is what we need for our balloon. When it is created, there is zero velocity, it is adding and adding and adding, and it's going up. Okay, you could stop here with adding a cloner and give some multi instance, and we'll turn this on for now. Do we need that balloon? Yeah, okay. And with cloner we can go for object and put it all object here, maybe scale, if you ever decide to do various scales, and it will work. But as you can see, maybe that's too much of particles. I'll reduce that to maybe 40 something. Let's hit play, and as you can see, maybe our landscape need a bit more size. Okay, that's okay. As you can see, the first particles are created, and the others are just popping up. That's because the animation is calculated with the real time, the time of our Cinema 4D's timeline. So when the animation works in this here, it stops for everything. Even though it is not shown up, it will be working. Okay, and now let's try something different. Okay, we may need this cloner for our boxes. So our boxes are not animating, so we can put it in our cloner, and we can use the multi-instance object, right? And we'll take this balloon animation thing and give it a tag of FoxParticles FoxShape tag, and there is no group, so we don't have to do that. And we just, if you turn this render instance, it will behave same as like our cloner. Oh yeah, right, we have defined our shape for our particles, but we don't have any particle objects here. This is not a particle object, this is an emitter object. For particle objects we need a TP geometry. You can add this thing here, or you can go with simulate, where's that thing, thinking particle, and TP geometry. Now the TP geometries are actually, you can move it because the movement is controlled by our Fox particles. Our TP geometries are actually the balloon thing, because we defined our shape here. If we didn't did that, it refresh, it won't be showing. We need our Fox shape to be defined what particle shape is, and our particle should be having that animation offsetted. Why is not offsetted? I think the order matters. Oh, sorry, the render instance is turned on. I'll turn it off and it will be offsetted with every particles. Okay, so that's the difference with the P shape and others too. Okay, and you get a nice balloon. I'll find a nice point to start with. Maybe that's the first one. So I'll put a camera here, maybe a little bit down, and let's hit play, and our particles are creating and having a balloon party here. And you can go with the Fox velocity in direction. We can give some variation of maybe 40-degree angle, and maybe in direction of X, not that much, 0.3 and 0.34 here too. So it will be having a small random sliding too, just like the balloons. And the particles, maybe we'll give some more 1000 frames, the life of 1002, and the particles will be increasing their velocity as they get into the air, and it's moving, boom boom boom. And why it's dying? It shouldn't be dying. Life is 100 non-stop. I don't know why it's dying. Maybe will increase the priority. Yeah, the Fox emitters also have priority now. And let's see here, we just increased our Fox emitter priority, so we'll increase our Fox velocity priority too. And it's working. It shouldn't be dying. It's not dying. Okay, now it's moving up. Oh, sliding too, right? You can see it is going offset of our landscape here, so that is having a small slide, right? So that's how we created that balloon. That's what is Fox shape tag is. That's what is velocity force is. Okay guys, that's it for this tutorial now. See you in the next one.